It's great to be here in Atlanta. I was at the PX4 Dev Summit a couple of years ago in New Orleans. I must admit it was a lot warmer in New Orleans, but I thought Atlanta was going to be warmer, so you just can't predict these things. But yeah, hopefully everyone's surviving the Arctic blast. We have Roboto socks at our booth, so if you're still feeling the chill, come and get a pair of socks from us afterwards. But anyway, I'm excited to talk to you today about how you can accelerate your PX4 flight review with AI. If we don't already know each other, as Ramon said, my name's Benji Barash. I'm the co-founder and CEO of a company called Roboto. We're building an analytics platform to help companies automate analysis of all of the data that their drones and robots produce so that you can improve your uptime and grow your fleet more reliably. You don't want to necessarily grow your feet. Before Roboto, I worked at Amazon Robotics and Amazon's drone program Prime Air, where I led some of the engineering teams there that were building autonomy platforms and simulation platforms as well. I tried to work out when I first worked with PX4. It was thanks to Julian Urs, who's of course one of the core contributors in PX4. He was working at Amazon at the same time as me in 2014, 2015. And when he left, we actually had a Pixhawk cake made for him that even lit up and played the music, which was definitely not allowed in the building, but it didn't matter. We got away with it. But anyway, I'm not here to talk to you about cake. I'm here to talk to you about flight review. I assume everyone in the room is deeply familiar with these screenshots, right? If you're not, I'm surprised that you came to this conference, but we would be screwed without flight review, right? It makes it absolutely possible to triage flights, debug issues, and it's a great tool that's community supported. I have completely lost track of how many logs I've uploaded to flight review in my lifetime, but it's too many, I bet. But there is a problem, and that's kind of why I'm here talking to you today. And that problem is that, as we know, drones produce a lot of logs, right? As you start flying, you start generating logs, and you get overwhelmed with all of those logs pretty quickly. And I'm sorry to tell you, but as your fleet grows, that problem doesn't go away. It just gets worse and worse and worse until you're kind of drowning in all of this data and really just not able to make heads or tails of it. And what we found at Amazon actually was that the ugly truth of the industry really is that most of this data never gets looked at, right? You're probably only really even looking at logs where you already knew there was a problem. And you're not necessarily looking at all the other logs where there might be ticking time bombs waiting to strike and waiting to affect a customer of yours at some point in the future. And we started to notice this. We'd have issues and crashes at Amazon, and we'd discover every time we had an incident, we'd ask ourselves, why couldn't we have caught this earlier? And almost every time the answer was, we could have caught it earlier. We could have caught it 3 months ago, maybe, but nobody was looking at the logs where, the problem was being exhibited. And so ultimately, issues and edge cases slip through. They reach your customers get angry. Maybe you're going to lose a business and they go to a competitor. And ultimately, that's just because your fleet is unreliable. And that sucks, right? What we also learned is that manual review alone really just doesn't scale, right? Like, unless you've got enough people and enough eyeballs and enough patient engineers to just go through every single log all the time robustly, it just doesn't scale up. And as we know, a typical PX4 ulog file might have, a couple thousand different time series signals inside, right? They're complicated. There's maybe 100 topics. Each topic's got a dozen fields or so. So the manual investigation is challenging and difficult. And as I said, as your volume starts increasing, you just start drowning in all of those signals. And the answer here is obviously automation, right? Like it's kind of obvious. You just got to start automating the analysis. But it's difficult to do that, and we need some smart ways that we can find important events in all of these logs and find needles in this haystack of information. And it's 2025 now, right? Like, AI is a thing. Hopefully, the solution here is we can just use some magical AI that can analyze all of this log data for us. But, I'm sure everyone in the room is a fairly kind of rational person. We're not quite there yet, right? Like, you can't just take a 200 megabyte, ulog file from a long flight, drop it into ChatGPT and be like, hey, ChatGPT, can you debug this ulog file for me? It'll probably be like, no. And you'll be like, okay, I'll upload it to flight review. So we're not quite there yet, but I'm going to show some stuff at the end of this talk that might give us some hope that things are moving in that direction too. So the approach we've taken at Roboto to help companies start automating all this log analysis is a slightly more pragmatic step. Essentially, what we're able to do is we can combine deterministic checks, the stuff that you know to be looking for and that the PX4 flight review kind of documentation tells you to look for, with generative reasoning that an AI LLM can kind of provide for us. And I'll kind of walk you through how that works in a second. But in order to solve that, what we also realized at the same time was there's actually a lot of different log formats that get used across robotics, right? I'm sure everyone in the room here is generating ulog files. If you have a PX4 system and you're also generating ROSBags, you might be getting kind of MCAP files or ROSBags associated with your ulog files. You might even be collecting journal control logs from your like Linux kernel as well, because usually that's where there might be USB issues or other types of problems inside. So you get a lot of different types of robotics log files, and we needed a way to also have a more standard interface to get data out of them. Because if we want to write kind of different checks and then feed that all to an AI, we need a more standardized interface. So one thing Roboto provides in the SDK that we've built, it's all open source, you can essentially just grab slices of data. You can get a topic of data. So on the right-hand side here, you can see I've just basically said, from this file, I just want to get the sensor mag topic. And from that sensor mag topic, I just want the X, Y, and Z fields. And once I've got that, I can do whatever I want with that data. And I'm going to show you in our system, we have this, this kind of capability of running actions. And an action just processes this data. And I've pulled up just real source code here from an actual action that just calculates the norm of the magnetometer and decides if the magnetometer kind of standard deviation was above some threshold. And if it was, we emit a tag like the magnetometer was unstable, something like that. But you can see how easy it is just to write an action like that and kind of do a useful check for something. Now, once you can do that, you can start writing a lot more checks and then use all of those together in a second. I'll show what that looks like. But imagine kind of as the PX4 flight review docs say, you should be looking for things like excessive vibration, GPS glitches, sensor clipping, estimator status flag issues, log message dropouts, and even other console errors that might just be in the standard console logs. So we've actually already translated all of the things that the PX4 flight review docs say to look for into these actions that I just showed you a preview of before. And we worked with some experts in the PX4 community to actually make sure we wrote those checks correctly. So now when you upload a log to Roboto, you can generate all of these checks and they'll produce some results that we call events. And then once the events have been generated, you can feed those events to an LLM. So we've kind of done a big dimensionality reduction in a sense, right? We didn't just provide a raw log file to the LLM. We provided sort of some outputs of checks that we know we need to look for, plus some context, which is always important, as we know with LLMs. And then that is able to generate for us a useful summary of what happened. So in this case, the summary in this, toy example I've got here might be the vehicle experienced some GPS glitches. At the same time, the cameras were overexposed, which led to a loss of control and maybe ultimately an emergency landing. So that's the kind of snippet and summary that our system can generate once you upload some logs. Here's a real one that we actually generated with some random logs that I just pulled off of the flight review server. It looks like a flight that someone uploaded from Vietnam. It's telling me like there were critically high vibration levels. There was a GPS jamming indication that was kind of higher than it should be, maybe some accelerometer clipping as well. But you can see it's turned kind of a very unstructured log for me into some specific things that I should now maybe go and look at. And I'll show you what this actually looks like in the platform. I'm clicking on a ulog file that's been ingested here. And then I can come over to the AI summary tab, and this starts generating the summary for me by consuming the output of all of those checks and the console logs and other such things. And you can see here, it's generating it on the left-hand side for me there. It's telling me it's probably too small to see for some people at the back, but it's giving me the state transitions that the vehicle went through. And then it's telling me, yep, there were some GPS and signal health issues. There were some log dropouts. There were accelerometer clipping issues. And actually, if I click on any of these things, I'm able to then visualize those aspects directly as well. It's going to pull up exactly the right data at the right time for me that corresponded to that check. So in this case, I was pulling up the power warning issue, and I could see the log line. And then I can even open up now the kind of map panel and 3D panel to try and figure out when in the flight that power warning happened, potentially. So you can see I just jumped into a log, got a summary, and now I'm immediately able to jump to the kind of points of interest in that log that it was telling me to look at. I'll just let it kind of play through here, but I'm just jumping around and clicking through some more events that were generated. You'll see in a sec, I think I click accelerometer clipping, and that pulls up the accelerometer clipping graph for me, and I can zoom in to the specific point in time where there was this accelerometer clipping issue and even kind of show and hide different events on that data to make it clearer what I'm looking at. So I just hid all the events. Now I only want to see the accelerometer clipping events. I can turn those on and boom, now I'm just looking at that shaded region where that issue was. So really nice and quick way to just debug and accelerate analysis. What we discovered after this was that because we can now generate a summary on a per log basis, you can also take all the summaries for all the logs over, say, a given day or week and generate what we call a summary of summaries, essentially kind of a report, if you will, where you can kind of feed them all in and then get a single rundown across all of your logs. So here's a real example that we might send to a Slack channel of a daily kind of AI rundown of all the logs you've uploaded, so you can get a sense of maybe different issues that you may have otherwise not been looking for. So you can see here it said there were maybe 70 flights today that got uploaded for this one user. There were critical vibration levels detected in one flight. And then in several flights, there were widespread communication dropouts that were detected. And it's possible that you might not be looking in your logs for widespread communication dropouts, but this is the kind of system that can then start surfacing those for you in a way that you'll find things you weren't otherwise looking for. So we're really excited about this. We think ultimately it enables faster triage and hopefully less manual digging. We think it will lower the barrier to entry as well for new engineers, right? I'm on the PX4 Discord all the time. People are always chiming in like, hey, I'm trying to fly. I just had this issue. Can someone help me interpret this log? What the hell happened? And if you're lucky, one of the maintainers will kind of spend their precious time to come and help you debug. So we're hoping it kind of reduces the barrier to entry there. We also think if you're a larger company and you're collecting a lot of logs, this can really help with scalable fleet monitoring, especially early detection of issues, as I was saying. And the key thing we've noticed in companies where we've deployed this already, it really helps to alleviate expert review, right? There's a few people usually in companies that are doing the lion's share of all the review, and it's not always a good use of their time. So, those people aren't going to get replaced in terms of this review, but hopefully they can spend their time on the issues that matter instead of having to review the same issue for the 100th time, right? I'm getting people nodding, so I think everyone's felt like that. So yeah, if you want to give this a go, check out our GitHub repo. You can pip install Roboto and make a free account. Most of our code for the checks is open source. Feel free to reach out to us on Discord as well if you want to chat about anything. But yeah, go and play with it. One thing I will say though, sort of from an AI analysis perspective, there can be false positives and false negatives. So, your mileage may vary. We've also noticed, you might overfit to past logs. If you upload tons and tons of logs from like an old version, and then suddenly you have a brand new version of logs, it's going to sort of naturally overfit to the kind of data you've uploaded historically. And of course, like any LLM, we know them and love them, but they can hallucinate and they can give incorrect summaries, right? So I just want to put all those disclaimers out there. But now I've given all those disclaimers, our team were kind of excited about also just seeing what an LLM could actually do if we just gave it access to the same tools that we give humans, right? So we have a powerful SDK. It lets you fetch slices of data. Our team was wondering what would happen if we actually just gave sort of an agentic LLM access to the same Roboto SDK that humans use. And I'll show you the results. We actually took a real log from one of the PX4 Discord discussions, and we're asking our agent here, can you please just go and perform a root cause analysis on this crash in this data set? And inside the data set, there are some PX4 ulog files. And what it does is it actually starts calling tools that our SDK has made available to the LLM here. And it goes on what I would probably describe as a treasure hunt. It starts with the console logs. It tries to decide at the end of the console logs, did anything interesting happen in this flight? And if it sees that something interesting happened, maybe there was sort of a sudden stop or a crash, it'll then work backwards from that and be like, well, okay, I could see that there was an error about some clipping issue maybe towards the end of the log. Why don't I go and pull the accelerometer data now? And then it will actually start doing calculations on that, and we make available to it a tool where it can do deterministic mathematical calculations. So it's not doing that in the LLM context, which would be maybe a little scary. But it's actually able, you'll see in a second when it finishes, it gives me a full report of what happened in this log. And it gives me a timeline of the critical events that it's debugged. And then one thing that's really cool, at the end, we asked it to generate a causal chain for the root cause analysis. So kind of just give us a summary of what led to what, right, that led to the crash. And you'll see here it's saying it thinks there was a mechanical vibration issue, which led to some accelerometer and gyroscope clipping, which ultimately led to bad accelerometer data going into all the EKF instances. And then eventually, the set points were bad, feeding into the position controller, and then the vehicle was kind of blind and crashed. And this log that we pulled off one of the forums, the person that had this issue reported later that they hadn't correctly strapped their IMU down to the drone well enough, essentially, and it was just shaking around during the flight. So actually, that is exactly what happened. It had an excessive vibration due to a hardware kind of issue. So Yeah, we were pretty impressed. We didn't think this was going to work as well as it did. We've not released this yet, but we're thinking of releasing it and just seeing what happens so people can play with it and let us know. Maybe there's a world where on the PX4 Discord, if someone comes in and asks a question, maybe this can automatically run and give them some initial analysis. So we'll see if we can wire it up. So anyway, long story short, we think AI can really help review flights at scale. You need infrastructure to store and post-process and analyze all this data to make that work, though. And of course, make sure you keep humans in the loop for any high-stakes decisions. We're not entirely replaceable yet. Thanks very much, everyone. Come see us at our booth if you're still around later.
Thank you, Benji. We got time for one question. Any questions? Yes.
Hit me.
Wait, not yet. Yeah, people in the video want to hear your question.
Okay, so I'm wondering, like, how does it scale? Where does it break when it scales? For a couple things, like, I could feed a lot more data into the log that nobody's going to really look at, but if this could look at it and make sense of it for them. Plus, like, what if we have like 10,000 logs a week or something? Like, do we just throw them all in there, or are we selective about, how many we want to feed it?
Yeah, it's a really good question. We make it easy for you to decide when you want to run that analysis as well. So in the system, you can set up what we call triggers, where you can be like, only run this analysis for me on flights that I've tagged with production, maybe in this location, for example, or only run this analysis on flights with software version this or hardware version that. So you can be very selective about when you run the analysis. In terms of scale, we've got some companies that are uploading several hundred flights a day into this and then doing large aggregation over them on a weekly basis too. So it's scaling pretty well. And that's obviously the benefit of the cloud. You can kind of distribute it. One thing that's nice too, we've got it set up so that you can run all this stuff serially. So you don't need to allocate too much compute to run it. Or if you do want to throw budget at it, you can be like, yep, I'm happy for it to have access to like 20 machines concurrently where it can be running all this analysis.
Cool. Yeah, I have put a few logs through ChatGPT. You just load the ULG file in there.
Nice. Exactly.
Any more questions? Yeah. Let me stop here, and then I'll go to Ian real quick.
Hey, awesome tool. I was just going to ask, I don't know if I missed it, but is the LLM like part of the pip library? Is it a local LLM, or which one are you using?
Yeah, it's a good question. So we're adding a support for a local LLM that you can plug in if you have like an Olama thing running locally. But right now, this is hitting AWS Bedrock, and we have kind of a self-hosted LLM within Bedrock that we're using. We find that works best because for most customer data that we're working with, they don't want it to leave the cloud that they're in, right? You don't want it to like phone home to some third-party AI company. But if it's in Bedrock within AWS or equivalent on some of the other service providers, then it stays in one place. Yeah. Also makes the installation easier actually as well, because you can use the local pip and then not need to install loads of stuff locally too.
Can you think of a value or reason for running the analysis locally, like on vehicle? Would that or pre-analysis or something? Can you think of a value proposition there?
I think so. I mean, it's probably just time to insight, really, right? Like for sure, running things on the vehicle is great if you can get answers quickly. There's some prevailing wisdom that there's a lot of GPUs that go idle on vehicles that are kind of offline, not really doing anything. So if you can use those GPU cycles, it might be cool to do that. One thing we've noticed though is that you only get so much insight from a single log, right? Like the beauty here sometimes is in the aggregation and being able to spot issues over lots of logs and maybe be like, yep, that vehicle is having a problem versus these other vehicles.
I guess the vehicle itself could keep its own logs at least, right?
Sure, yeah. But it's still going to be its own single data point in a way, right?
Anyone else? All right. There's the one last one. I'm going to give it a chance to just go.
Ramon's going to sprint to the end of the room.
Yeah. Oh my God.
It's the last exercise of the conference.
While I do this, Anastasia, do you want to start getting up there, please, so we can...
I have a question related. For example, if I want to do something more than just reviewing the log, right? Just check events, but get some statistics in general, right? Like custom stuff. Let's say I need some information to do endurance information, right? And then kind of compare next logs to future logs with that information. That can be done there, like custom stuff.
Yeah, 100%. So in that same action system that I was describing, you can run your own custom code. So you could say every time a log gets uploaded, I want to run my custom script and I want to output this information. And then with our SDK, you can then aggregate all of that still. So that's a very common use case for us. Like, users or companies will be like, we think we've got a barometer issue on like a bunch of vehicles right now, but we don't know which. And they'll use all the logs and all the sort of custom scripts they've written to aggregate all of that and then figure out, it's this 1% of our vehicles right now that have this barometer issue. That's super common.
Great. Thank you.
So
Thanks,
much,
everyone.
Benji.